Okay. I just check here. Okay, so you got that one. I don't know where's the other one. Should I check it?
Oh, did he?
I just check.
He didn't reply. He probably here, but he didn't know where.
Yeah, I know. That's why I want to check it.
Okay.
Now we're going to do inductance. So the difference between inductance is that it stores magnetic field rather than voltage. It's magnetic field and well, voltage and magnetic field are different. You know that, right?
Yeah.
Okay. So it stores magnetic field and it discharges magnetic field as well. But let's just get the overview of it so you can like apply it to solving the circuits. You know? So for inductance, voltage is equal to L di dt. Okay. For capacitance, you say C dV over dt. For inductance, you say L di over dt. Just remember those two. So L di over dt. So your L will be followed by di over dt, and your C will be followed by dV over dt. Because you will know, right? If you have this, is it going to be a voltage or is it going to be a current?
That would be a current.
Yeah. So if you have this, is it going to be a voltage or is it going to be a current?
Voltage.
Yeah, it's a voltage. So because it's you're multiplying the inductance with the voltage. You can also think of your inductance as resistance. You know, it's almost the same. They belong to the category of impedances. Have you heard of that? Impedance. Okay. So impedance is divided into two. Impedance is like it objects to the flow of current. So like it doesn't let the current pass through whatever. That's right. There's impedance, and it's divided into two. First is resistance, and then the second one is reactance. So resistance is just linear. It's not a function of time. Mostly it's just, when you say Ohm's law, your V is equal to what? I times R, right? That's your Ohm's law. But in the reactance thing, you consider time. So it's like it's varying with respect to time. That's why you say your voltage and your inductance is the over dt. Okay. So impedance, you have resistance, and you have reactance. Reactance is composed like capacitance, capacitive impedance, and inductive impedance. Yeah, so you have those. So when you say, and then all impedances, like one of my friends were asked like, what is an impedance? And she's like electrical, and she didn't know what to do. She didn't know what an impedance is. All impedance are in ohms. Okay, so all impedance in ohms because it opposes the flow of current. So you know that. Like you know how the resistors work, it opposes the flow of current, right? Do you think so? When you put a resistor right next to the voltage, your current flowing into the circuit is reduced, right?
Yeah.
You don't believe that?
Yeah, I do.
No, I mean, like, I can show you an example though.
No, I do.
Okay.
I don't know.
Okay, so this is your voltage for inductor for your V of I up to dt. Okay. For your okay. Now we would like to get the current across the inductance. What is it? So we would like to get this one.
L. It's L. It's also the same, but over R.
So 1 over L, right?
And over R. And 1 over R.
Equal of. Wait. So we would like to get v dt. L di over dt, c dv over dt. So v dt, right, equals L d I of t, right? Right? So your I of t equals what? How do you do this?
V dt. L. I t.
We would like to get I, right? So that would be 1 over L v of t dt, right?
Yeah.
Let me double check that just to make sure that's correct. Does it make sense to you?
Yeah.
I don't know, but it's relatively new to you. But so that's I of t equals 1 over L v dt. Okay. So okay, so that's cool. I don't know if you use that, but so those are the formulas that we have. 1 over L equal d of t dt. Okay. Usually your d of t is just the same, but because your voltage source is it's varying too. Because it's a AC circuit, so. Okay, let's just make an example. It's just all theory right now, but you don't know, you don't really understand it. So we will do is to make a circuit. Yeah. For example, you have this. So this is your resistor, and then you have a capacitor, and then you have an inductor, right? So write me the equation of this thing. R, C, L. Okay. Okay? Try. Write me the equation of the loop. So when you do the loop, you do KVL, right? You know how to do KVL? Kirchhoff's voltage law? Like, that's it. You don't know that? You don't know KVL? Okay. So for example, we have. Okay, let's do this one's our resistor, right? Let's try this. Let's see. This is a resistor. Then you have 2 resistors, right? So this is your I. Right. So this is V minus, right? Minus R1, R2. Have you did this in your class? I times R1 minus I times R2 equals 0. Because KVL equals 0, right?
Yeah.
You remember?
You did it one time, but I forgot it's KVL.
Okay. Oh yeah, it's KVL. That's what I did. So you do V minus I, because you kind of like say that that all the voltages in the loop is equal to 0. When you sum up all the voltages, it's equal to 0. So it's like, do you remember that? Did you try that in your house? You do KVL?
No.
You just, so what you do is you just like solve for resistor equivalent, right? Like for example, you have L series, like those kind of stuff. Okay. So let's try with resistors then. I thought like you were doing this already. No, that's okay. Let's try that. So for example, we have let's say this guy. For this guy. So let's say this is 2, this is 1, this is 1, this is 10. Okay. Try solving for the equation of the KVL. Okay, let's just say R1, R2, R2. Try solving for the KVL equation. So you wanna like reduce that to just like this simple circuit, right? So first, your first step would be simple circuit, right? And then you write the equation. Remember? So you have a parallel resistors, and you do KVL.
No.
Right? So let's see. That's your R total?
Yeah.
Correct. So, nice. That's almost correct, but not this one.
Oh, right. Oh.
Correct? Yeah. So, yeah, that's the equation of your KVL. Correct. So how about if you have a capacitor now? So you reduce it to this thing, and then you do that. You say V minus that, and whatever minus that, and then equal to 0. That's your KVL. I thought you were taught this already though. I was doing it, and then I never realized that you were just doing that.
The cumulative resistance comes up fast.
Yeah.
It's like, I think like one day before the midterm.
Oh, he taught you that? One day before the midterm?
I think.
Oh, the KVL?
Or he's like rush.
Okay.
Rushing it, so.
So that's okay. So now, okay, what is the equation of this thing? Did he give you like this? Something like that, then write the equation? No? Like resistors, and then you write the equation?
Okay.
Probably not, but it's okay. Okay, so you do KVL. Okay. And what is the voltage across the capacitor? So voltage across the capacitor is that's correct. Yeah. So I should have said that this is because you know what's the difference between AC and DC? Do they teach you? Not yet, I guess.
No.
Not yet. So just like basic circuit. So that's what what's going to happen. For example, I have another. Okay. How about? Okay, let's see. Let's try. Do you know nodal, like current going in equals current going out? Do you know that? So for example, if you have a node, if you have like current I1 here, you have a current I2 here, I3. Did you teach you that? No, yet not. Okay.
No.
Okay. So just basic. Okay. So how about if you have okay, so this guy is an inductor. Okay. What's your equation? So that's L.
Oh.
That's L. Okay. So try to memorize the basic, and then so that you can apply it in your so okay. So what is this? Okay. Let's do a review. I hope that you remember that.
I copied that.
You wrote it down.
I wrote it.
Okay, but try to fill it out on your own as a review, the conclusion. Let's try. What's your voltage for R? Perfect. And then what's your current for your R? Okay. Then what's your voltage for your C? What's the basic first? So
G?
No, like write it down first.
Oh.
So what's the no, it's just the basic, the ones that I your fundamental. Is it like C or IDT? Okay. Alright. How about so where's that? So that's I for C, right? Just fill out the ones that you know for now. You know what I mean? Just fill out the ones that you know.
I forgot.
Okay, no. So this is, what is this?
C.
No, what is this? I, right. So where is the column?
Oh.
Okay. You will not forget that. Okay, what's the other one? LDIDT, right? LDIDT. Write it down there. LDIDT. No, LDIDT. What is that?
V.
Oh, it's V, right? Okay. So where is that? Where is it in the column?
Yeah.
Okay. Okay. And okay, so now you don't have the voltage for the capacitor, and you don't have the current for the inductor. So maybe you should manipulate this guy to have your voltage, right? Okay. So how would you do that? Okay. Okay. Down. Perfect. Oh, so your I is a function of time.
Oh, okay.
Good. So what's your E for your transport? Okay. When you say dt, it's not a function. So when you say dt, it's not the function of L. Okay. So now you have one more. I for inductance. You can erase the whole thing. So you have LDI over dt, right? And that is what?
That's V.
Okay. Now you want to get the I. So great, yeah, that's great. Now get the I.
Can you
L is a constant. Okay. Yeah. So L is a constant, V is a function of time.
Oh,
So,
oh.
L is a constant.
Oh.
Yeah, that's okay. I think you know it. Okay. Yes. So like I think when you do your new class, you're just gonna be he's just gonna give you like simple circuits. And the ones that you
Yeah,
just solve.
but
That's the and then it's gonna be like, what's the equation of this? Maybe it's gonna give you something that's parallel, but we can talk about it next time.
Okay.
But just copy this one. You copied it, right?
I did.
Okay.
I wrote it down.
Okay. So you can, at least you have some idea. Is it so bad? You just go to a class where you know nothing about it.
Yeah, it's so bad.
And bring your exams.
Okay.
We'll solve more problems next week. Like a lot more.